All right, 7-2 is similar polygons. This is our second day of Unit 7. Yesterday we went over ratios and proportions. Ratio is comparing two values. Proportion is comparing two ratios.
Do you have tutorials tomorrow?
All right, and we're going to start off by looking at what it says at the top. To identify a similar polygon, similar polygons have the same shape but not necessarily the same size. So, a congruent polygon is the same size and shape. It means the angles are congruent and sides are congruent. A similar polygon, for it to be similar, it's like one step down from that. The angles must be the same so that it has the same shape. So congruent angles, but the side lengths don't have to be. So the sides don't have to be congruent. So angles are congruent, sides are not congruent. You can have the same shape, but be a different size. Okay, so then the first example, it says to list all pairs of congruent angles and write a proportion that relates to the corresponding sides. Okay, and you write, so we have the similarity statement given to us already. Triangle ABC is similar to triangle XYZ. So notice the symbol. That's not, it's just the little squiggle that's on the top of the congruent sign. It's not congruent. That one means similar. And the angles are still matched up in the same order. So angle A and angle X are congruent because they are listed first in the same position. So angle A and angle X are the same. B and Y are the same. And C and Z are the same. So whenever, and that's what it says here, it's, I guess I could have just looked at that. So the second part said and write a proportion. So we have this extended proportion because there's three ratios to make the proportion. We're looking at what's like which angles are making up the sides. So if I'm looking at C to B, it's the purple to the green. So on the other triangle, I need the coordinated piece. So from purple to green. So that's CB goes with ZY. And then the next one, it doesn't matter which one I pick. I could go green to red, as long as I go green to red in the other one. So BA and YX. And then the last one, I'm going to go red to purple. So I need to go red to purple. And so AC and XZ. All right, so notice mine isn't exactly the same as the proportion they gave, but both are correct. It just depends on the way that you do it. And also notice, I have C on top of Z. Look at that. C is the one that's congruent to Z. A is on top of X, A is congruent to X. B and Y, B is on top of Y. So the congruent parts match up like that. And also notice all of the numerator is one triangle. CBBAAC, that comes from one triangle. The denominator all comes from the other one. ZYYXXZ, that's all in the second triangle. So numerator, denominator, it doesn't matter for this as long as you are consistent, and you can end up with a different proportion than someone else. So you just have to make sure that it works. Okay, so then it says on example 2, determine whether the pair of figures is similar. If so, write a similarity statement and a scale factor. So are these similar? Well, let's see. Are the angles the same? Angle W has one line, and angle P has one line. Angle Z has two lines, and angle S has two lines. Angle Y has three lines, and angle R has three lines. And angle X has four lines, and angle Q has four lines. So yes, each angle has a matching piece in the other figure. So these are similar. The sides are clearly not the same length, but that's okay for similarity. And then it gave us the corresponding angles are congruent. And since corresponding sides are proportional, okay, so now we need to check to see, is it similar by comparing the sides. So if I look at, this one said WX and PQ is 12 and 8. I'm looking right here. Is 12 over 8. If you reduce that fraction, it reduces down to 3/2. And then you look at the next one, XY and QR. And that's 18 over 12. But that reduces down to 3/2. And then 15 over 10 reduces down to 3/2. 9 over 6 reduces down to 3/2. So when the fraction is in simplest form, it's the same for each side. So that means that they are proportional, and they have a scale factor of 3/2. And then it says or 2/3. So that depends on which direction you're going from one to the other. In this case, the way it's set up, WX is in the numerator. So it's starting at WX and it's going to PQ. So this one is the start and this one is the end. So this one is the numerator. Oops, and this one is the denominator. Now if we could still set it up, because this problem doesn't tell us which direction to go. If we set up our proportions from going from the small one to the big one, then our scale factor would have been 2/3. It would have just flipped. Should make sense. So you start to end. So the numerator is the one that you're starting with, and the denominator is the one that you're ending with. All right, so here we have some exercises. List all pairs of congruent angles and write a proportion that relates to the corresponding sides for each similar polygon. Okay, so we have D and G. So D and G. So angle D is congruent to angle G. E is paired up with H. So E is paired up with H. And then we have angle F with J. All right, so there's the congruent angles. And now we need a proportion so we can figure out what the scale factor is. Oh, it doesn't ask for that. We don't have numbers. We can't figure that out. It just says a proportion that relates. So it doesn't really matter where we start. If I do D to E, so side DE, then I have to have the matching one in the other. So I went red to blue, so I need to go red to blue. GH. And EF, blue to green, goes with HJ, blue to green. And then the last one, if I go green to red, FD, that matches green to red, JG. And again, if you started in a different spot or went a different direction in naming your sides, then your letters are going to look different. But this already tells us that this is similar, because we have the similar statement. So we're not trying to prove that it's similar. We're just saying how it is similar, because we're already told that it is. I'm not going to do the second one, because I feel like that's probably pretty, that y'all get that. On the next part, it says determine whether the pair of figures is similar. So this time we don't know that they are. We're not told that they are. If so, write the similarity statement and scale factor. If not, explain your reasoning. Okay, so number 3. Are these figures similar? No. They are not similar. Explain your reasoning. They have the same number of sides, don't they? Yeah. But I feel like what stood out to me is that this is a regular shape, and this one is irregular. And you can tell because angle L is 90 degrees. There's not a 90-degree angle in the other. Another way we could have said this is angles are not congruent. So, not similar for, you say it however you want. Okay, on number 4, are these two triangles similar? So we have to see, do they have congruent angles, would be the question. Do they have congruent angles? Well, here's an angle with a single line, angle P. And it's congruent, so we'll call that of the little triangle. That's congruent to angle P of the large triangle. Does everyone agree with that? Because they share that angle. What about the second one, R? R has 2 lines. And T has 2 lines. So that means that angle R is congruent to angle T.
Yeah, it's because they match, right? It's because they're matching.
Yeah, they have the same number of lines, so that means that they are congruent. And then angle S has 3 lines, and angle Q has 3 lines. So I actually have to say angle Q, to keep the order matching, is congruent to angle S. So so this is similar. It says, if so, write the similarity statement. So I need to do that now. Triangle, if I go with the left column, PRQ, is similar to triangle PTS. So it's saying the small triangle is similar to the large triangle. And then, since now I know that they are similar, I can calculate their scale factor. And I'm only given one side with numbers, so I have to use that side. right? I can't, there's no other way to calculate because I only have one set of numbers. So if I say, let's see, QR, it didn't ask for this part, but I'm going to go ahead and write it out. QR over ST, it's a ratio of its sides. And I can fill in the value, that's 11 over 22. And then once you get it into simplest form, you reduce the fraction. Then you have a scale factor. So 1/2. 11 is half of 22. So my scale factor is half. If I start with the small triangle and go to the large triangle, which is what I indicated in my statement, sort of, from the large to the small, then it is 1/2. If I went from the large triangle to the small triangle, my scale factor would be 2 over 1. And you would go ahead and write that as a fraction, 2 over 1. So, or scale factor, just depends on which way you set it up. All right. So that's similarity statements and scale factor. And then on the back, we have some more stuff. So that first line tells you what we're going to be talking about on this side of the paper. It says you can use scale factors and proportions to find missing side lengths in similar polygons. All right, so I'm going to look at the first example. It says the two polygons are similar. Okay, that's useful. I don't have to prove it. It's telling me that they are. Find x and y. So to do this, since I know that they are similar, I can set up a proportion to find the missing piece. So when I set up my proportion, if I'm solving for x, I need x in the proportion, right? So if x is on side ST, from one line to 2 lines, then in the other triangle, I find 1 line to 2 lines, and that's NP. So x over 13, which is what is right there. And then I need another one, a known set. So I see in the little triangle there's a y. So I don't want to use that because then I'll have 2 variables in my problem, and that makes it more difficult. So I want to use the 16. So if I use the 16, that's from 1 line to 3 lines. So on the other one, from 1 line to 3 lines. That's where the 32 is. So I'm using 16 and 32. Since the x was in, I put the x in the numerator because that's where I want it if I'm solving, because it saves a step in the solving process. Since I put x in the numerator and x was in the big triangle, that means the 32 also needs to be in the numerator when I do the other fraction. Because it has to be consistent. You have to be consistent in how you set it up. And from there, you're just solving for x. You could do it the way the paper shows with the cross product property, cross multiply and divide. Or really, since x is in the numerator, you just multiply by 13. 32 times 13 divided by 16, it'll give you 26. And then you can do the same thing to find y, using the y and the 38. All right, I'm not going to go over the second example. I'm just going to go to the exercises. And it says, again, each pair of polygons is similar. That's important information. Find the value of x. All right, since I'm solving for x, clearly x needs to be in my proportion. And I could actually go ahead and set it up. Fraction equals a fraction. And I'm solving for x. So I want x in the numerator. Okay, so then in the other triangle, I need to find the piece that matches x.
And 9.
From 2 lines to no lines. So from 2 lines to no lines. Yes, it is a 9. So x and 9 go together. So since I put x in the numerator, I'm going to put 9 in the denominator. And then I need another one. Well, I need the 12 because the large triangle only has one other number to use. It's 12. 12 is from no lines to 1 line. So from no lines to 1 line is 8. X was in the numerator, so 8 needs to be in the numerator because 8 is from the same triangle. 12 then will go in the denominator just like the 9 because it came from the large triangle. And now I'm solving. So solving for x means multiply by 9. Get that 9 out of the bottom. So x equals 8 times 9, which is 72, and then divide it by 12, so it's 6. And I'm not going to spend a lot of time on the algebra part right now. We're just looking at the geometry part, because this is some basic solving stuff. Okay, number 2. I already know that these are similar trapezoids, and I want to solve for x. So first find x, because you got to use that piece. There it is. And these are facing the same direction with the matching parts and the same angles, so that makes it very easy to figure out which ones you're going to use. So I'm going to use that for my first ratio. X over 4.5 is going to be equal to another ratio. So the only other number in the large trapezoid is this 10, and the 10 matches the 5. The 10 is in the large trapezoid with the 4.5. In my ratio, 4.5 was the denominator, so I'm going to put 10 in the denominator. So that means 5 is going to go in the numerator. And then solve for x. So since I have x over 4.5, I want to get 4.5 out of the bottom, so I multiply. If I do it on one side, I have to do it on the other. So x equals 5 times 4.5, and then divide it by 10, is 2.25. And please stop and let me know if you have a question as I'm going through this. Be glad to stop. Talk about it. Number 3. Again, if I look at my two figures, they are facing in the same direction, and I double check real quick to make sure all the parts, the angles are in the same positions, and then since these are, it makes it real easy when identifying your pieces to set up your fractions. Let's do it right here. A fraction equals a fraction, and I need to use x.
X goes in the first place, right?
Yeah, because I want x in the top. X plus 1.
Okay, x plus 1.
Mm-hmm. And then the piece that it corresponds with in the other figure of the same side, x plus 1, it's the 24. So the 24 goes where? Right, in the denominator. And then for the other one, in the large quadrilateral, I only see one other number, so I have to use that one. It is 18. So does this go in the top or the bottom?
Bottom.
The bottom, because the 24 is in the bottom. And then what goes with the 18 in the small figure?
18.
You have to have the one that matches. 18 was from 1 line to 4 lines. So on the other one, it's from 1 line to 4 lines, so it's the 12. So the 12 goes in the numerator on the other side, so that means this other 18 is just extra information. My screen froze? Yeah, so that 18 in the small figure is extra information. You don't need it. Don't worry about it. So now I need to solve. So I want to multiply by 24 to get it out of the denominator. If I do it on one side, I do it on the other. So now I have x plus 1 equals 12 times 24 and then divided by 18. And you end up with 16. And now there's one more step because x plus 1 is 16. So that actually means that side length. X plus 1, that is 16. But if I'm solving for x, I still subtract 1. So x equals 15.
How did you get 16?
12 times 24 and then divide by 18. Because that gives me 288. And then 288 divided by 18 is 16. Okay, 2 more examples. You know what? Number 4 is just like number 3. I'm going to give you guys more time to work. Let's just look at number 5. If ABCD is similar to PQRS, find the scale factor of ABCD to PQRS and the perimeter of each polygon. Okay, so we know that they're similar because it says ABCD is similar to PQRS. And we're told to find the scale factor to go from ABCD to PQRS. That is very, very important as to which fraction your answer will be. Since it designates a direction that you're moving from ABCD to PQRS, this one, the one on the left, and so that's the start and this is the end. We're starting on the little one and we're ending on the big one because it says 2. Very, very important. So the start is going to be the numerator. So this one on the left is going to be the numerators. And on the right will be, the large one will be the denominators. All right. So now we need to match up 2 sides. On the little one I have a 14 and a 20. And in the big one all I have is 25 and none of those sides match up. But if I look here at my statement and I see AB and that matches PQ. So AB and PQ, I could set up a ratio there if I only knew what the length of PQ is. Does anybody know what the length of PQ is? Yeah, 25, right? Because of that hash mark on it. It has a line on it, and so does the other side. So that if the bottom is 25, then the top is 25 also. So I can set up a ratio of AB over PQ because those are matching pieces according to the statement. And I only really need to find one side or ratio because it tells me already it's similar. So all of the sides are going to have the same ratio, the similarity ratio. So 20 is AB and 25 is PQ. So is that my scale factor, 20 to 25? 20 over 25? Yes or no?
Yeah.
No. No, it's not. You have to reduce it. It's almost. It's equal to our scale factor. It's just not actually the scale factor. The scale factor is always in reduced form. So 20 and 25, you can both divide them both by 5. So you end up with 4 over 5. That's the scale factor. They have a similarity ratio of 20 to 25, but the actual scale factor is 4 to 5. All right, so that's the scale factor. And then it also says, find out the perimeter of the polygon. That's easy. Easy stuff. You guys can do that. So the top of the little one is 20. So then the bottom is 20. The left is 14, so the right is 14. Perimeter just means you add it all up. So we have 20, 40, 50, 68. So we have 68 is the perimeter for the small one. 25, 25, so far we have 50. But we don't have the sides for that one, so how can we find out what the sides are? But we do know what the sides for the small one are, right? So what if we did the small one and multiplied it by the scale factor? You get 17.5. So 20 times 4/5 would not give me 25. So 17.5 times 2 gives me 35. And then the other part was 50, so that's 85. So scale factor is always tricky. So the scale factor is 4/5. So it's saying the small one is 4/5 of the size of the large one. Since I started at the small one, the small is 4/5 the size of the large one. But since I was calculating the large one, I had to flip it over to 5/4, a number that's greater than 1. And I multiplied the 14, the side of the small one, times 5/4 to get the 17.5. So you do have to keep it in mind when applying the scale factor. Do you need to flip it or not? 4/5 is a value that's less than 1. So it's going to make your number get smaller. It's like multiplying by a decimal. It's going to make your number smaller. Think 1/2. It'll make it smaller. 5/4 is greater than 1. So if you multiply a value times that, it's going to get larger. And then, so we have 68 and 85 for the two perimeters. And you have an assignment in your online textbook.